In this video, you're going to be learning about something called scales of measurement. In particular, there are 4 different scales of measurement that you're going to be learning about. And these 4 basic scales are arranged in order by the amount of information they provide. The first scale is going to provide basic information, and the last scale provides the most information. But what's important about these scales of measurement is they help us to determine which type of statistical test can be used. So we definitely will be using these scales of measurement. As I introduce them now, they're just sort of these separate scales that might not make a whole lot of sense, but just hang in there. Just have some good examples of what the scales are and you'll be golden. All right, the first scale is nominal. And this is a scale that's used to describe the quality of something. It identifies and categorizes something, and it can be represented by numbers, but the numbers do not mean anything numeric at all. There's no quantitative ordering of these numbers. And performing mathematical operations on a nominal variable would be inappropriate. So as we're doing statistical tests, we know that we can't find the mean of a nominal variable, for example. So what are some examples of a nominal variable? Well, it's really anything that you could put into categories. So gender is a nominal variable. Although definitions of gender are changing, gender as we typically think of it as having an identity, you can categorize that. People's emotions can be categorized: happy, sad, mad. These are different categories that people might have. Your personality, extrovert, introvert, these are categories we can put people in. I might label my categories, category 1, category 2, category 3, but again, I can't do any math on those categories. So let's say, for example, that I have the categories of Republican, Democrat, and Libertarian, and Green Party, for example, 4 different categories. And I label the Republicans 1 and the Democrats 2 and so on. I can't do any averages on those numbers. They don't mean anything. They're just labels, basically. And that's the nominal variable. Nominal variables are very, very important, but they are basically just categories. The second level of measurement is ordinal. Think of ordinal as categories with an order. You might want to write that down. Ordinal scales of measurement have an underlying continuum, meaning that things do have a rank order. It represents a degree of quantitative difference, and the variables can be ranked. They can be rank ordered. The differences between the rankings, however, might be unequal, and therefore you cannot do any math on an ordinal variable either. So there's no mathematical properties associated. So what are some examples of an ordinal scale of measurement? Well, sizes: small, medium, and large. Those are 3 different categories, but those categories have an order from smaller to larger. Another one might be your year in school: freshman, sophomore, junior, senior. Those are distinct categories, but those categories have an order, so it's an ordinal variable. So we say that the differences between the rankings may be unequal. Here's an example of how this works out. And I've got this ribbon here, so you can take a look at that for a reminder that maybe we're running a marathon. I've run a few half marathons in my day, and I've never placed in a half marathon. I did get 3rd place in a 5K once, but I digress. Anyway, so we have maybe the 1st place finisher, the 2nd place finisher, and the 3rd place finisher. This is an ordinal variable, the finishing places, the rank order. But the distance, or the amount of time between 1st place finisher and 2nd place finisher, might be different than the time between the 2nd place finisher and the 3rd place finisher. And so those distances in between the rankings are not equal. They are most likely unequal. And so this is an ordinal variable. It's categories that are placed in an order, but the distance between each category is can't really say that it's equal. The next scale is interval. Interval also has an underlying continuum or quantitative dimension, just like an ordinal scale, but the points on an interval scale have equal intervals. So the units between the intervals is equal. So an interval scale is ordinal except for the fact that the points in between the units is equal. So equal intervals means that there's equal amounts of the quantity being measured, and probably the best example of an interval scale is a thermometer. You know that the degrees have an equal distance in between them. And for a thermometer, there's theoretically no bottom. There's no bottom temperature. There's no zero temperature. The last scale is a ratio scale. And it's going to be similar to the interval scale, separated by equal distances. However, in a ratio scale, we actually do have an absolute zero. We didn't have an absolute zero with the temperature, but we do have an absolute zero on a ratio scale. And so because we have this absolute zero, we can do all sorts of math with it. So it's kind of fantastic. But let's think of some things that are examples of ratio scales. Well, a scale that you might weigh yourself on has an absolute zero, and all the increments are equal distance. Time is an example of a ratio scale. Weight, length, your scores on maybe a standardized test such as the SAT or the GRE. Anything that has an absolute zero to it and equal distances between the points on the scale is a ratio scale. Okay, we have a learning check. We have nominal, ordinal, interval, and ratio. Pause the computer and match them up with these descriptions on the side. I'll be here for you. Okay, here are the answers. Nominal are telephone numbers. There's numbers involved with them, but the numbers don't mean anything mathematically. They just categorize people into different categories, so to speak. Ordinal, the rankings of Pac-12 basketball teams. So we have a first place team, a second place team, etc., but the distance between them is not necessarily something that we can measure. Interval, temperatures in Safford, Arizona. There's an equal interval on a temperature scale, but there is no zero. And ratio, distance from Budapest to the U.S. cities. Budapest is the zero starting point, and then the miles to different U.S. cities is a ratio scale. All right, I hope that this was helpful for you. In the last video of lesson 1, we're going to go over some statistical notation that will carry you through this course. So I'll see you there.